equal mc square.
Good evening, sir. Welcome to Law of Conservation. It's a pleasure to have you.
Thank you.
So we'll just start with a few light teaching related questions. So, do you have a favorite concept to teach to students, and if yes, which concept is it?
Personally, my favorite's always been algebra. So any algebraic related topic is something that I am more interested in teaching. Yeah.
So when you learned algebra, were you from the beginning? Were you completely do you like the subject?
I struggled a lot in algebra, and I think that was the motivation. Yeah. So I could handle geometry better, and algebra was quite a challenge. So I struggled with equations and so many x's and y's and z's and all that. And then I think that was where I started enjoying it because of the struggle. And yeah.
So did you have one teacher growing up, or do you have multiple math teachers?
Multiple teachers at school, one at home, my father.
Oh, right. So is there any one mathematical concept you think we should introduce to students at a younger age?
Definitely. I think proofs should be introduced to students. I mean, when I studied, I remember we were told to mug up proofs back in India.
Okay.
So we didn't understand how those proofs evolved. But now when I teach the MAAIB course, particularly the HR one, they've added proofs to that course, and you really enjoy. You make students think how do these ideas come up. And that's not covered in any other course, even the Cambridge, or if you look at middle school, those things are not covered. So just simple proofs. And if you have the Pythagoras theorem, how do you prove it? So if you can have such small things there, it would be more interesting. That's what I feel. Yeah.
Do you have a favorite proof, sir, by any chance, that you like teaching more or like solving more? A favorite proof, proving the Pythagoras theorem or proving something else. Is there any favorite one of yours?
I enjoy doing the proofs in trigonometry, but they are regular identities that we prove. Yeah, that's quite fascinating when it becomes a little challenge. Remember the one we did recently?
Yeah,
something like that.
So in the subject of IB, is there one thing you change about the IB curriculum in the mathematics subject, or do you feel like it's a good curriculum or?
I feel it's already a well-balanced curriculum, so I don't think there's anything to change as such. But personally, yeah, if we could have paper one without calculator even in the MEI, you should not be just totally dependent on a calculator. You should be able to do things mentally also. Yeah.
Are there any chapters that are taught later in maths in university or college that you would like students to take up in high school?
Definitely. Some things like, so these used to be part of the old HR syllabus, like some elements of number theory, some of group theory. These could be at least touched upon in the IB syllabus so that people get an idea of what they should expect when they go to university. They just don't go there and realize this is something completely new or something completely abstract. So I feel some things like that should be part of your course. Yeah.
So you taught university math, you taught high school math. Which one do you enjoy teaching more? Do you have a favorite, or do you think they both are the same level?
Personally, I think university math is more enjoyable. Yeah, there's less discipline issue there. Only the people who want to do it would be there. The others would not be there. So in high school, you don't have a choice. You have to study math. So everyone's around there.
So what do you think about exams? Do you think there should be very close, frequent exams, or do you think there should be once and twice a month or
Okay, I don't think there should be exams too often. And I think certain exams should be open book. So have everything in front of you. Have your laptops, have your internet, have your books, and still give you a tough question which you can't Google out, you can't find out, but then you at least think and you have all the tools in front of you. You can't say, oh, I forgot the formula, or I probably saw it in some other question, I just did not remember that. But if I had everything in front of me, and if I can replicate that, or I can extend those ideas to an unseen problem, that's where I feel it's better learning. Yeah.
Did you write such exams in your university days?
Yes, in fact, I conducted such exams.
Okay.
Yeah, I did.
So how do those happen? Is it first to solve gets the most marks, or how do they?
No. I just gave them I used to give them open book tests. So they had their books, their laptops, everything, and then they realized, this question, which topic is it from?
Wow.
So completely blanked out. Okay, because you have the book, now you don't know which page should I open on.
Yeah.
So that becomes more challenging, and then you realize, oh, this is from this topic. It's also from that topic. It's on this page. It's on that page. I didn't read the book at all.
Proofs is
So
definitely
so
yeah.
you need to have.
Definitely.
So like you taught university in IB, so is there any advice you like to give students like transitioning from high school to college? About college or about the mathematics in college?
Definitely, I would suggest, I mean, those who are interested in studying university maths should consider reading in depth, extend your topic. So if you're doing calculus, don't stop there with the IB calculus. Go ahead, read about double integrals, read about triple integrals, read about something more in those topics, because eventually you are going to do that. Yeah. So don't just stop after your IB boards. Finish some more. Enjoy maths is my main idea, rather than just being afraid of it and trying to get to the answers. Probably look at the elegance in the approach.
So you probably studied physics at some point in your life. Like, how do you view the relationship between maths and physics, and how do you think like they overlap or like motivate each other as subjects?
They definitely motivate each other. Physics comes up with a problem. Mathematicians supply the tools. So we kind of give you the tools. I remember one instance when a friend of mine who was with me in college, he is now doing his postdoctoral research in Illinois. He told me that he wanted to write a couple of papers, but he needed mathematical support, for which he spoke to me. Unfortunately, for some reasons, it didn't take up. We couldn't go ahead with that. But yeah, physics and maths are very closely related. However, I also quote some examples like this. Let's say you want to build something, a wall, and a person takes 10 days to build it. Now, if I give you 2 people to build the wall, you'd say, okay, probably done 5 days. If you look at it that way. If I give you 5,000 people, can you do it in a couple of seconds? Physically, it's not possible. Mathematically, you will see the limit is approaching that thing. So, there are some places where you cannot connect the two. So then you got to think about what happens in the physical world and what happens in the mathematical world. There is some subtle wall, I would say, between the two, but not at all times.
So coming to like hard questions, is there one question you remember from like your university or school that was like the hardest question you ever seen? Is there like anything like that?
I don't really remember any hardest question as such, but I remember one particular area of maths in which I struggled a lot. That was differential geometry. It was quite confusing for me, and I took a lot of time to understand those concepts, because in university they don't really spoon feed you. They just tell you these are the tools, these are the theorems, go and read. So most of the study is done in the library. You've got to find time, sit in the library, get up some books, and only then you can understand those things.
So talking more about mathematics, and obviously maths is everywhere in our present world. So which, in your opinion, do you consider to be the greatest application of mathematics in our daily lives, or on a macro level as well?
See, applications, I mean, of the maths that we study in the IB, you can find them around us. If you look at calculus, you find speed, distance, time, all these things are around us. But personally, I wouldn't look at applications. I mean, because maybe I'm inclined towards pure maths. I'm inclined towards how maths is built up rather than how it's applied. So when I study maths or when I teach maths, what I intend to do is to talk about or to share the elegance or the beauty of deriving something or arriving at a solution rather than looking at the applications.